Drive wheel axle. Drive wheel axle made by HS consists of final drives, which are interchangeable. There is no left or right one. Either of the final drives can be installed on any side. Only the control spots and oil filling spots are different. Disc work brakes, 2 axle shafts, each having joint sleeves, which makes it easy to dismount the gearbox. You won't have to dismantle the final drive. Then goes the parking brake, which is operated by a hydraulic cylinder. To activate it, the driver presses the button on the control panel. Gearbox. It has 3 stages. On the top of the gearbox, there is a selector mechanism connected with a cable. It goes to the cabin and there, it is attached to the lever. Here, on the switching mechanism, there is a neutral position sensor. Further on, there is a speed sensor, a breather. On the left side of the gearbox, a hydro motor is attached. The work brakes are the disc brakes. You can use either side separately, but on hard surface roads, it is prohibited. Such type of split braking is only allowed on the field. The master cylinder reservoir is located behind the cab, between the cab and the grain tank. It is covered with a special iron shield. The calipers are located next to the gearbox. The gearbox has 3 stages. The first one is for harvesting in difficult conditions, such as on mud or on slopes. The second one for conventional harvesting, and the third one is the transportation mode, without the adapter and with an empty grain tank. Switch between the stages only when the parking brake is not activated. The shaft is blocked and it's very difficult to switch between the stages. To select one of the stages, the parking brake must be deactivated. Also, before you switch off the harvester, make sure to put into neutral. This harvester has got an engine start blocking system. If the gear is left in the neutral position, you will not be able to start the harvester's engine. To unblock the system, you have to deactivate the parking brake. The parking brake is hydraulic. You can put it on and off only if the engine is working. As an option, you can use a semi-track unit. This one is used for harvesting rice. Instead of the front wheels, a semi-track unit is mounted. The front axle must be properly equipped for installing the semi-track unit. The indicative of the possibility for installing the semi-track is the presence of such a disc or plate, which the semi-track will be attached to. In this mode, the first stage of the gearbox is prohibited. Because the RPM is pretty high, the movement speed is pretty slow, so use the second or the third stages of the gearbox. Steerable axle. Don't forget to screw the bolts all the way in after transporting. If you don't screw the bolts to a hard stop, or even forget to do that, if the combine starts shaking, the bolts will start hitting the bar, which will lead to the cracks in the bar itself. So after unloading the harvester from the transporter truck, don't forget to screw the transport bolts all the way in. When mounting wheels on the harvester, always use the given table to make sure you use the right torque for tightening the nuts. If the wrong torque is applied, the bolt head may come off, leaving the bolt shank in the wheel hub. Steerable axle fed SLE. This construction is quite simple. Here, there are cylinders for steering, which control the turning of the wheels. The option that is used currently is the drive axle produced by Rostselmash. The wheel hub installed there is produced by Fed SLE. Here, you see the two greasing points. The first adjustment you need to perform is the wheels toe-in adjustment. Perform the adjustment only when the wheels are not loaded. Use the jack to lift the harvester before the adjustment. Align the wheels and make two measurements in one plane. Take the measurements on the edges of the discs. The distances here and here. If the distance from points D and E is within the range of 0 to 6, the toe-in parameter is normal, so the adjustment is not necessary. If the difference is bigger, perform the adjustment using a cross tube. The tube has lock nuts on its ends. Loosen the nuts, and rotating the tube, adjust the parameter. So adjust the parameter to fit the range from 0 to 6 mm. Another option available is a four-wheel drive harvester. In this case, the steering axle installed is TDS drive. It is a part-time four-wheel drive. To use this function, press the button on the control panel. Please note that to activate the four-wheel drive, the harvester speed must not exceed 12 km per hour. If the speed is higher, even pressing the button, you will not be able to activate the four-wheel drive. Here, you can also adjust the toe-in using the measurements of M and H. As you see, the procedure is similar. As to the direction of the herringbone tire pattern of the back tires, if you're not using a four-wheel drive harvester, you should swap the wheels so that the herringbone pattern is directed against the harvester movement. If you have a part-time four-wheel drive, only this direction of the herringbone pattern is possible. The tire pattern direction depicted on the lower figure prolongs the tire's durability, especially if you have to drive on hard surfaces like asphalt. If the harvester is primarily used in the field, the direction of the herringbone pattern is not important. Motor unit. Currently, our harvesters are equipped with the following engines: Cummins QSG12 or Mercedes MTU OM460LA. Exported combines are equipped with Cummins engines. It has AdBlue particle filter. The horsepower is only 520. Straight 6. The nominal RPM is 1900. As to Mercedes engines, two options are available, of 425 horsepower on Torum 750, 506 on Torum 780. Grain loss calculation. To calculate the grain losses, you have to make a 1 square meter tray yourself or buy measuring equipment. We have used a ready-made equipment. These are 3 trays. The size of each tray is 0.3 square meters. We threw the trays under harvesters and measured the losses. If you decide to make the trays yourself, make them as wide as the thresher. The length must be enough to make a square meter. The width of the thresher is roughly 1.5 meters. So the width of the tray will be roughly 70-80 centimeters. What you have to calculate is the grain loss per square meter behind the combine. Measure the losses only in the windrower mode. If you start measuring losses in the threshing mode, most part will be spread across the field and not in the place of measurement. That's why you throw the tray behind the thresher and measure the losses there. Another feature of Torum harvesters is that in this place, both chaff and straw are spread. That's why you will be able to measure the losses after separation and the rotor. After calculating the losses, you have to identify the source of losses. Either it's the rotor or the separation unit. When your tray is ready and the harvester is moving, following all the safety regulations, throw the tray under the harvester so that it gets to the output area of the thresher. Then, carefully shake the chaff and straw off the tray. Make sure that the grain stays on the tray. Precision in this procedure will help you calculate the losses correctly. Here, we're using a special device, which is actually a tube and a fan. The fan is powered by a battery located beneath, which makes this device portable. Charge the portable battery, and you will be able to use the device in any point on the field where there is no power supply. The device blows everything away but the grain, which is heavier than the rest of the mass. So as you see, the full tray is shaken off onto the fan. If you don't have a fan, you'll have to do it manually. Naturally, the procedure will take more time. There are two ways to calculate the losses. If you don't have scales, you'll have to calculate the quantity of kernels per square meter. In case you have scales, first weigh the tray without kernels, then weigh the tray with kernels on it, then calculate the losses in grams. Then recalculate the losses per square meter using the following formula. For instance, after weighing, you have got 26 grams of kernels. In 1 kilo of grain, you have 21,276 kernels. The 26 grams after weighing equals X kernels. So, the X value equals 26 multiplied by 21,276 divided by 1000, which equals 446 kernels per square meter. The given data can be received after agronomic evaluation. Or you can use the average data. The given table shows the quantity of average-sized kernels per kilogram. Also, you can weigh 50 or 100 kernels and then make the calculations using the formula. After you have calculated how many kernels you have per square meter, put the data in the calculation formula. N is the quantity of kernels, then goes the width of the thresher, then goes the width of the header in meters. Here we use the amount of average-sized kernels per kilogram, or you can use the data provided after agronomic evaluation. Then goes the yield, 100 weight per hectare. Multiply it by 10,000, the value of width is 9. Then goes the quantity of kernels multiplied by 50. The result is 0.7% loss. Such loss is within the normative range. Up to 2% of loss behind the combine is considered to be normal, which accounts for 1.5% after the thresher and 0.5% after the header. The above-mentioned figures show that the harvester is adjusted properly and is ready for work. In case the loss value is higher, the harvester has to be adjusted to lower the losses. There can be different reasons for high loss value. First, you have to identify where you have got more loss, after the rotor or after the cleaning. On the Torum harvesters, do the following procedure. The mass after the rotor and the separation is blended into one stream. To calculate the source of loss, you have to exclude one of the parameters. Although you cannot stop the rotor, you can open the separation unit and lower the fan RPM. Naturally, all the mass will go into the grain tank, but this way, we will understand that if we still have losses, the losses come after the rotor. If during this procedure the losses disappear, the problem is in the separation unit. Bear in mind that you throw the tray or try to detect whether the rotor or the separation unit is the cause of the losses only after 20 meters of harvesting. The thresher is not fully loaded at the start of harvesting, and the losses are always bigger at this stage. When the thresher is fully loaded, the losses decrease, which is standard for harvester operation. After you have detected whether the problem is the rotor or the separation unit, use the following guidelines to detect the possible reasons of grain loss. The difference of Torum 785 drive axle by HS. The drive axle on Torum 785 is similar to the ones on 750 and 780. The difference is that in standard configuration on 785, the axle is equipped with half-track mounting discs. Another difference here is the electrohydraulic transmission. As you see, it's not mechanical anymore, there's no cable wire. There is a valve body with sensors for switching the gears. In the cabin, there is a gear changing unit that has 5 positions. And positions have neutral gear, and between them there are 3 stages. The conditions for selecting the stages are similar. Difficult harvesting conditions is number 1, number 2 is for conventional harvesting, and the third one is the transportation mode. The conditions for switching gears are working engine. The harvester speed must not exceed 0.5 km per hour, and the hydrostatic transmission knob is in the neutral position. Only under the above-mentioned conditions is changing gears possible. If you try to change the gear when the harvester is moving, it'll have no effect. You'll have to stop the harvester, set the knob in the neutral position, and only then change the gear. On this harvester, an emergency gear change is possible. The hydraulic unit has got 2 plugs. They're colored black, but inside they are green and red. The red one is longer, the green one is shorter. They're used for an emergency gear change. To choose the correct stage, you have to remove one of the plugs. On the right, we have got plugs A and B, and on the left, C and D. B and C are for the front shaft of the combine, if you get under the feeder house. The nearest shaft will be B and C. This means switching the second and the third gear. Shaft A and D, the one located further, is the shaft for switching the neutral and the first gear. If you have to change the gear from the second to the third, or vice versa, remove the plugs B and C. To switch the gear, first remove the plug. There might be a minor oil leak because there is a hollow behind the plug, and the pressure pushes the shafts. You'll have to do it manually. Unscrew the plug B. If the third gear was switched on the shaft, and you need to switch on the second gear, remove the plug B. Then, first, screw in the green plug. It pushes the shaft to the neutral position, like in the image here. Then screw out the green one and screw in the red one. It'll push the shaft to the second gear. Bear in mind that every time you switch gears, you do that after the neutral position using the green plug. So if you try to screw in the red one, here, it will be physically impossible. The stem will not reach the thread, so you won't be able to screw it in. So first use the green plug that will push the shaft to the neutral position, and then screw in the red one. The same procedure is done on another shaft. For example, if you want to switch from the third to the first gear, first remove the plug B, screw in the green plug to switch off the third gear, then put the plug in A or D to switch on the neutral or the first gear. Maintenance. Types of maintenance. Daily maintenance is performed every 10 hours. There are 3 types of daily maintenance. The deviation from the intervals is allowed only within 10% range. If you know your machine needs service, be sure to notify the maintenance staff beforehand. Carter bar drive. Please note that when applying lubricant on the lower bearing, make 1 stroke every 10 hours. Excessive lubrication will result in premature bearing failure. Lubricate the upper bearing with 5 strokes every 50 hours. Stone trap cleaning. It is necessary to clean the stone trap. If the field is not too stony, or not stony at all, clean the stone trap at least once a day before harvesting. Having too many stones in the stone trap may lead to stones getting into the feeder house, so try to check and clean the stone trap as frequently as possible. Rotor support. Rotor support bearing lubrication. If you unscrew the hatch, you will see the rotor support with 2 marks. Roman numerals 1 and 2. Here are the 2 lubrication points. Under mark 1, you lubricate with lithol. But before doing it, unscrew the central bolt. Keep filling it until the fresh lubricant is visible. After the procedure, screw it back on. Under mark 2, there is a graphite lubricant. Use it to lubricate the bearing cup. Use only graphite lubricant because this spot has high temperatures. And if you apply lithol, it'll melt and leak. Rudder deck reduction gear. At the top, it has a breather hole, which is also a filler neck. On the side, there is a control plug to check the oil level, and on the opposite side, there is a drainage plug. Change oil for the first time after 100 hours, then after 1000 hours, but not less than once a season. Use gearbox oil. Rudder drive reduction gear Walterscheid. The oil tank volume is 16 liters. Change oil first time after 100 hours, then 500 hours, not less than once a season. Near the right wheel, there is a rubber hose with a plug. It's the oil drain spot. Use Shell Amala S4GX 150 or a similar oil, Rostselmash G-Profi Output 150. On top of the gearbox, there is a breather and an oil level dipstick. You can fill the oil through the breather or through the plug next to it. Oil level check procedure. Unscrew the breather. Take out the dipstick, wipe it, put it back inside, and screw it all the way down. Then take it out. Check the oil on the marks. It is considered to be wrong to simply unscrew, wipe, and insert it until it touches the gearbox and then check the level. This type of oil check is considered to be inappropriate. In the lower part of the gearbox, where a lubricating system intake tube is located, there is an oil filter. Check the filter condition in case of pressure drop. Wash it if necessary. It is an iron net filter. Feed auger cone reduction gear. The filling point may not be found on most new harvesters, but the drain plug and control plug are found on the reduction gear. You may not find the greasing point, but filling, checking, and drain points are found on the reduction gear. Change oil every 250 hours or once a season. Use transmission oil Rostselmash G Profi. Vertical auger reduction gear Bondioli. Fill it with Rostselmash G Profi oil. For the first time, change oil after 500 hours, then after 1000 hours, but not less than once a season. On the gear, you can see the oil level control plug on the right. Below, there is a magnet drainage plug. Don't forget that such magnet plugs require frequent removal of metal chips. On the left, there is a breather and a filling plug. Next to it, there is a greasing point for lubricating the bearing. Angle reduction gear Bondioli. It doesn't require frequent lubrication, only every 1000 hours or once a season. To conduct the maintenance properly, the following procedure is required. This greasing point is used for lubrication. But first, open the hatch, unscrew the plug, and start filling until a fresh lubricant is visible. As soon as you see the fresh lubricant, use the hex key to screw the plug back on. Then open the lower hatch, unscrew the similar plug below, start filling until the fresh lubricant is visible, and screw the plug back on. This is how you properly change the lubricant. Front driving axle HS. On the right, along the motion of the harvester, there is a control plug. Below, there is an oil drainage outlet. On top, there is a breather for oil filling. Change the oil, 11 liters, after the first 100 hours, then every 1000 hours, but not less than once a season. Use Rostselmash G Profi and the same oil on the final drives in similar intervals, 8 liters each. On the top, there is a breather. Below, there is a drainage outlet and 2 control plugs, but we always use only the lower one. There are 2 plugs because the final drive can be left or the right one. So different plugs are used depending on the final drive position, but only the lower one must be used. Power unit. Oil level check in the engine. Engine oil must always be at the proper level. The volume of oil is 39 liters. Change oil every 250 hours or once in 2 years, depending on the counted hours. Use Rostselmash G Profi Supreme MS 10W40. Coolant level. Coolant level is checked daily. The system has a sensor that signals if the coolant level is low. Change the coolant once in 3 years. Coolant type, glycentine GO5 ready mix. Air filter cleaning. Clean the filtering element only when the harvester is switched off. Take the lid off, take out the first filtering element, which can be maintained. Clean it with compressed air only in the inside-out direction. The pressure must not be higher than 4 bar. If the second filter gets dark, change the first and the second filters. If the second filter isn't covered with dust, clean only the first filter when the sensor goes off. Air filter protective element replacement. Do not clean or reuse the second air filter protective element. If you see the layer of dust on its surface, replace both filters. Transfer reduction gear watershed. Change oil after the first 100 hours, then after 500 hours, but not less than once a season. Use the oil types from the list in the user manual. The volume of oil you change is 10.7 liters. On top of the gear, there is a breather, which is also an oil level dipstick. Below, there is a tap that you open to drain the oil from the gear. Check the level on the dipstick. To do this, unscrew it, take it out, wipe it clean and screw it back all the way in. Then take out again and check the oil level. Also, when maintaining the reduction gear, dismount and clean the oil filter when you change oil. Transfer reduction gear Bondioli. If the harvester is equipped with transfer reduction gear Bondioli, it has a higher oil volume, 14.8 liters. The oil change interval is the same. Here, you see a separate dipstick and a breather near it. The drainage is similar to the one on watershed. Cleaning the fuel tank and the filter. To remove the sediments from the fuel tank, open the tap and keep draining until clean fuel appears. Fuel filter water separator. Fuel filter water separator has a pump. To start pumping, release the bolt and begin the bleeding procedure until air stops emitting from under the bolt. Below, there is a glass reservoir where you can find sediments, fouling, and moist. If you see some of the above-mentioned elements, open the valve and start draining until only clean fuel appears. Hydraulic system. Change the filtering elements every 500-600 hours, but not less than once per season. These are the 3 filtering elements: the filtering element of the hydro tanks and the body of the filter, the filtering element on the harvester hydrostatic drive, and on the pump of the rotor hydrostatic drive. Cleaning the breather. Every 500 hours, unscrew the breather, check it, and if it's dirty, clean it with compressed air. Oil change in the hydraulic system. Use our brand's oil, Rostselmash G Profi Hydraulic Ultra Pure. If you're planning to start the combine at lower temperatures, change the oil in the hydro system to Gazprom Neft Hydraulic HVLP 32. This oil is used when working at temperatures of up to 20 below zero. The total oil volume is 133 liters, including all hollow parts like pumps, motors, and other elements. Change oil after the first 500 hours, but not less than once per season. Then, after 1000 hours, or once per season, or after a long period of storage. Even after your harvester has worked only 50 motor hours, you have to change oil before starting the next season. In case of premature oil change, replace the filtering elements as well. To change oil, first drain it. Open the valve at the back of the harvester. On the left, there is a drain valve from the hydro tank. Drain the oil completely from it. Then move on to the hydro motor located on the gear. Below, there is a half coupling. Unscrew it and drain the oil from the hydrostatic drive. Start filling at this point as well, until oil appears in the check window of the harvester's hydro tank. Then move on to the half coupling located on the feeder house on the left and fill it up to the necessary level. This half coupling is also used for topping in case of minor damage or oil leak. In this case, the system must be filled with oil through this half coupling. Oil drain from the hydro system. Oil drain from the hydro system is similar. Oil change on Torum 785. This procedure is similar. Drain oil from the hydro tank and hydrostatic power transmission. This is a protective cap, under which there is a half coupling through which you fill the system. The difference is that the half coupling is located not near the feeder house, but right on it, near the reverse hydro motor. The filling procedure is the same. Start from the hydro drive and finish on the coupling. Cabin overview. The steering column has got 3 adjustments. On top of the wheel, there is a nut to adjust the height. Then the lever to adjust the inclination of the upper part, and below, there is a pedal to incline the whole steering column. The steering column has got indicators and switches. Number 1 is an understeering switch. It controls transport lights, swiveling headlamps, and sound signal. It also switches on the windscreen wipers. Number 2 is steering failure indicator. Currently, this indicator is not used. Number 3 is the general failure indicator, which goes off in case of electrical system failure. This type of failure will be also shown on the display. At the same time, you will hear voice notification, and this indicator will be blinking. Number 4 is the emergency alarm switch. Number 5 is tail and stop lights indicator. And number 6 is a winking lights indicator. The sound signal is controlled in 2 ways. The first one is pressing the button on the handle, and the second one is pressing the button on the hydrostatic drive joystick. The sound signal device is located under the cab. Engine start locking. There are 2 ways of blocking the engine that won't let you start it initially or repeatedly. The first engine locking is activated when the range's position switch is not neutral. Until you set the range's position switch into the neutral, the starter won't rotate, so you won't be able to start the engine. The second blocking is activated when someone accidentally turns the key when the engine is working, so the starter won't turn on repeatedly and won't break down. In the top part in the cab, there is a lights control panel. The first button controls the tail lights. When you press this button, all the other buttons on this panel and inside the cab are backlit. The backlighting on the steering column is also activated. In the front and back lights, the tail lights indicator is activated as well. Transportation lighting. It can be activated only when the tail lights are on. First turn on the tail lights. Then, moving this lever forward, you switch on the transportation lights, the ones located in the harvester bumper. External working lights. The next button activates 3 headlights on the left and 3 on the right. 6 headlights in total, which are controlled with this button. The next button controls the 4 central lights in the roof of the harvester. The next switch is for controlling the back working lights. They include the lighting of a grain tank, unloading zone, and chopping spreading system. Here are the 2 lights for the chopping and spreading system. This one for unloading, and this one for the grain tank. The last button switches on the flashing beacons. The flashing beacon switches on either with the help of this button, or it switches on automatically when the grain tank is 75% full. The sensor that gives the signal is located inside the grain tank. You can also adjust its height. The sensor activation time can be changed by moving it up and down using these holes. There are 2 flashing beacons. One of them is located near the rear view mirror and one at the back of the harvester. The climate system control panel has got 3 switches. The very left one controls the fan speed. It also switches on the air conditioner. The middle one controls the cool air, and the last one controls the warm air. There are some important moments to be taken into consideration while maintaining the climate system. For example, if you replace the compressor, you have to replace the receiver and O-rings. If the system is covered with metal shavings, you have to change the whole system. After winter period storage, you have to rotate the clutch manually. You have to do it if the clutch is activated. Set this switch into the first position without starting the engine and rotate the clutch manually. Make 10 revolutions manually to perform the lubrication so that the next time the start will be smoother. The control panel is located in the armrest. The first buttons we will look at are the buttons for controlling the engine RPM. There are 3 of them. The button with the snail is for the idle running. After the engine is started, it switches to the idle running mode. The next button with the turtle is for intermediate revolutions. It is used for starting the working units. The next button with the hare is for nominal RPM. It's the nominal engine RPM for conducting the harvesting. You switch to nominal RPM after all the working units are switched on. The RPM control can be also done in the automatic mode. When you start the engine, it's in the idle running mode. Then, if you don't press the turtle button and switch on the thresher, the RPM will be increased to intermediate and the thresher will be activated. In case the RPM is nominal, before you switch on the thresher, when you start the thresher, the RPM will automatically decrease. And then, the threshing and separating unit will be activated. In the settings section of the display, there is an engine tab. Here you will see the RPM values for each button. Here, none of the values can be changed, neither in the manual nor in the automatic mode. This section only contains information. The next button is the feeder house reverse. Reverse can be activated only when the feeder house drive is switched off. The display shows off icon. Also, we can't use the reverse function if there is a road mode icon on the display. In this mode, not only the reverse function is blocked, but also all the hydraulic units. nothing will work except the engine RPM control. Please don't forget that when you switch on the reverse, the reel is automatically lifted. The next set of buttons is used for controlling the reel RPM. Pressing plus and minus, you can increase or decrease the RPM. The change of parameters controlled by these buttons depends on the selected mode. If you're using the synchro reel, it's an automatic mode. In this mode, the reel speed is changed together with the speed of the harvester. The plus-minus buttons change the rate from 0.5 to 2.5. This rate sets the speed of the reel in proportion to the speed of the harvester. How fast or how slow the reel will be rotating depending on the harvester speed. Based on these values, we can see that the reel speed can be twice slower or 2.5 times faster than the speed of the harvester. When this mode is selected, here under the reel icon, there is a sign Auto, and next to it there is a chosen rate. The average rate which is normally selected is 1.2 or 1.3. Thus the reel speed is 20–30% faster than the harvester speed. If you stop the harvester, so the harvester speed is 0 km/h, the reel RPM becomes minimum. As soon as the harvester starts moving, and the harvester speed is more than 3 km/h and up to 15, the reel speed will change as well. When you move the header to the transport position, the reel will rotate with the minimum speed. This will happen when the header position will be higher than the transport position on the field copying system scale. If the reel sensor speed is out of order, this mode will be unavailable, so the automatic mode will not work. The next mode is the manual mode. When you select the manual mode, by pressing the plus-minus buttons, you will change the reel rotation speed in km/h. You set the desired speed, for example 5, 6 or 7 km/h, and the system will automatically maintain this speed. When this mode is selected, you see the sign showing km/h. The reel is automatically started when the feeder house drive is switched on. The rotor rotation speed adjustment is done with these two buttons. The rotation speed is controlled on the screen. In the section marked by this icon, waterside reduction gear has got two ranges. The first range is 220 to 600 RPM. In the second range, the speed changes from 550 to 950 RPM. On the display, the icon shows that the first range is selected. If you choose the second range, the Roman numeral 2 will appear. If you have to change the range, press this icon and the additional window will appear. In this window, you will be able to change the range. Press 1 or 2 to do that. Here you see the current selected range. 0 shows the rotor RPM. To switch to the first range, you press the button and wait. Sometimes, after you press the button for the first time, the mode does not change. The teeth of the sprockets go onto one another and the mode is not selected. In this case, the rotor is slowly rotated forward After the rotor stops, the system tries to switch the range again. If the range is not switched for the second time, the system shows the error, and you hear the voice notification. Then the error is recorded in the log.
If the second attempt is successful, you will see that the range will change to number 1. The same happens when you change from the second range to the first one. So if the first attempt is unsuccessful, try the second time and wait for the system to switch the range. You can make up to 5 attempts to switch the range. In most cases, it's not a malfunction, you just have to wait until the system manages to switch the range. If it's Bondioli reduction gear,
when you press this button, you will see two options, regular and emergency rotor start modes. The emergency start is used in the case of rotor clogging. So if the rotor is clogged, you can try and choose this option and start the rotor drive in the emergency mode. In this case, there is a chance that the rotor cleans itself and then switches to the regular working mode. If the rotation is not possible, you will have to clean the rotor manually. If it's Walterscheid reduction gear, choose the first range and then try to start the rotor. In this case, there is a chance that the rotor will clean itself. And again, if it doesn't happen, you will have to clean the rotor manually. So if the rotor does clean itself, it will switch to the regular working mode. If rotation is not possible, you will have to clean it manually. In case Walterscheid reduction gear is clogged, you have to choose the first range and then start the rotor. It may clean itself, otherwise manual cleaning is necessary. The fan speed is controlled with the help of plus and minus buttons. Here, there are no limitations. While the thresher is working, simply press the plus-minus buttons to control the fan speed. RPM is monitored on the display. The fan speed range is from 250 to 1000 RPM. The electric adjustment of the sieves, there are two ways to do that. The first way is to use the switches on the left side of the harvester. There, you can also find the windows to control the sieve clearance. Looking through the control windows, you set the necessary clearance. The second method is controlling the clearance on the display. You press this button, the additional window pops up, and in this window, you will be able to choose and set the necessary clearance. After you have pressed the button, there is a 2-second delay, and after this delay, the sieve clearance adjustment starts. The control panel also has buttons to set the sieve's clearance. On the display, you can select the automatic adjustment according to the chosen crop. Such parameters as rotor and fan speed and the sieve's clearances can be applied and set automatically as average values. To activate the automatic adjustment, you have to start the harvester and start the thresher. The engine RPM must be nominal. After this, the Apply button will be active and you will be able to set the automatic parameters. The next button is Vibra Agitator. When you activate this function, the back wall of the grain tank starts vibrating. It helps to shake off the wet grain which is stuck to it. This function can be activated only when the grain tank is 1/3 full. The function is active while you're holding the button. These buttons open and close the grain tank roof. The left one opens and the right one closes the grain tank roof. You don't have to hold the buttons, you just press it once and the roof starts opening or closing. When the roof is opening or closing and you're pressing the button of the opposite movement, the process stops. When you press the opposite movement button again, the movement to this direction starts. There are some limitations. For example, the closing of the roof is blocked when the cleaning is on. It doesn't really matter if it's Torum 750 or 780, although their grain tanks are different. The closing button is blocked when the thresher is working or cleaning is on. When there is a signal that the grain tank is full, the closing button is also inactive. The upper sensor, one of the two, the lower sensor, is for switching on the flashing beacons, and the upper sensor is for informing the driver that the grain tank is 100% full. When this sensor goes off, the closing button is blocked. To exclude the accidental pressing of this button, and if you try to close the grain tank roof when the grain tank is 100% full, it may damage the loading auger. Because it's inclined when the roof is closing and unfolded when the roof is opening, the system of rods and the mechanism can be damaged as well, and then you will have to repair them. That's why in these cases, the closing of the roof is blocked. In the harvester with a 12 cubic meters grain tank, you will also have the notification that the roof is open. The 4-wheel drive option is activated on the control panel. For this option, a different rear axle is installed. It has additional hydro motors. Also, there is a hydraulic distributor to activate the hydro motors when this button is pressed. This option improves the harvester's soil trafficability in difficult harvesting conditions. The activation of this function has got limitations. If the harvester speed is more than 12 km per hour, this function cannot be activated. If the harvester speed is lower than 12 km per hour, when you press this button, the rear axle is switched on. The speed gets lower, but the soil trafficability of the harvester improves significantly. The next button activates the parking brake. The parking brake is automatically blocked every time you switch off the engine. After you switch on the engine, the parking brake is not unblocked automatically, even if it was deactivated. Every time you switch on the engine, you have to press the parking brake button to deactivate the parking brake. The activation of the parking brake is blocked if the harvester is moving. If the harvester speed is more than 0.5 km per hour, when you press the parking brake button, it will not be activated. If the driver has for some reason forgotten to switch off the parking brake and moved the joystick to start the movement of the harvester, and the harvester manages to move, the driver will hear the notification about the attempt to start the movement with the parking brake on. On the hydro cylinder of the parking brake, there is a nut. It is used for manual unblocking of the parking brake. If for some reason you cannot start the harvester, for example in the case of some breakdown, also you won't be able to unblock the parking brake. You will not be able to unblock the parking brake because of no pressure in the system. Tighten this nut, and the parking brake will be unblocked. And then, you will be able to transport the harvester. After transporting, loosen the nut, and the parking brake will return to its normal functioning condition. The next button activates the rotor and cleaning. To switch it on, you have to pull it. Pull this part of the button up, pressing the yellow lock.
The button will go up, thus you will switch on the cleaning rotor or the thresher drive. There are two reasons why the thresher will not be switched on. The first one is the signal from the threshing and separation unit sensor. If there is no signal from any of the sensors, the system will block the start of the cleaning rotor drive. You will also hear the voice notification that the threshing and separation unit is in the wrong position. Then the condition of the sensors must be checked. You also have to check the position of the magnet. It must be located opposite the sensor. In this case is the threshing position sensor. If the thresher is in the windrower position, the sensor goes off and the magnet approaches it. The distance between the sensor and the magnet must not be more than 5 mm. This is the optimum distance for the sensor to work. The second reason why the rotor may not be started is the selected rotor range. The rotor reduction gear has got two sensors. They identify the selected range, range 1 and range 2. If there is no signal from any of the two sensors, the rotor won't start. You will also hear the voice notification that the rotor position is not detected. In this case, the driver has to press the button to select the range or check the condition of the sensors. If both conditions are present, one of these two sensors responded, and the selected range sensor responded as well, the rotor will start. If the pressure in the power reduction gear is not normalized after rotor is started, and will be not within the given range, the set range is from 0.15 bar to 7.5 bar. Then, after 5 seconds, the feeder house is stopped. If the pressure is not normalized, the thresher will switch off and the engine RPM will change to idle running. In this case, you have to check the oil level in the power reduction gear. This blocking may appear when the wrong sensor is selected. In the settings of harvester configuration, there is a section for selecting the sensor type. It can be a power reduction gear sensor. In this case, we're talking about the power reduction. For this, you will have to choose the Danfoss sensor. If you choose high duck, the rotor and the feeder house might be switching off constantly. The next button activates the feeder house and the reel. It has the same activation principle as the thresher button. When the driver is not on the seat, this button is blocked. This symbol must not be blinking on the display. If it's blinking, but the driver is in the seat, you have to check if the sensor is malfunctioning, or look for some problem in the electric circuit. In this situation, neither the feeder house nor the unloading will start. Multifunctional joystick. This button is used for the sound signal. The first button is for moving the unloading auger, folding and unfolding. This button has got two positions in each direction. It has two levels of pressing, lighter and stronger, and in both sides. In the system settings, there is a point, grain unloading. Here you can adjust the folding and unfolding time of the unloading tube. If the setting is 0 seconds, only the manual mode will work. If you set an interval, for example 10 or 15 seconds, After you press the button, the auger will automatically fold or unfold. It's not necessary to hold the button. The manual mode will work when you press the button lightly. The first position of the button, for folding or unfolding, is an automatic mode. While you're holding the button, the auger is loading or unloading. If you set the specific interval, when you press the button harder, the automatic mode of folding or unfolding starts. The length of the process is according to the previous setting. If you set the time of 3 or 5 seconds, it doesn't mean that the auger will unfold in 3 or 5 seconds. It means that after 3 or 5 seconds, it will stop in some intermediate position. It may not fold or unfold completely. So set the realistic time for complete folding or unfolding of the auger. If unloading is activated, even if you set the time and press the button harder, the automatic mode will not switch on. In this case, it will be set as manual by default. It is done to prevent the accidental folding of the auger during grain unloading process. While correcting the position of the auger, the driver may accidentally press the button harder. In this case, the auger will not start folding, and it will prevent the massive spilling of grain. So when unloading is on, the hard pressing of the button switches on the manual unloading mode. As soon as you switch off unloading, you can use the automatic mode. Press the folding button harder. The auger will fold automatically, and you won't have to hold the button. The loading and unloading activation is done by pressing the yellow button on the joystick. To activate unloading, press the unloading button on the joystick and hold it for 2 seconds. Then you will hear the voice notification, and the indicator on the display will start blinking. After the unloading drive is on, the indicator will stop blinking and become steady. To switch off unloading, press this button again, but you don't have to hold it. Just press it once. The unloading will finish and you will hear the voice notification that the unloading is over. If the driver is not present, the unloading is blocked. If the driver is present on his seat, the indicator is not flashing, and the unloading will switch on. If you see that the seat indicator is flashing, the unloading will not switch on. The next button on the joystick is the real position change. When you press it, it moves up or down, forward, backward. This function does not have any limitations. You can use this function anytime. The next button is lifting and lowering the header. It also tilts the header left or right. If you press the lateral buttons, you will tilt the header. These buttons have only one pressing level. The buttons for lifting and lowering have 2 pressing positions, the same as the buttons of folding and unfolding the auger. There is a lighter and harder pressing. It works for lifting and lowering. In case of lighter pressing, the header lifting speed is slow. The same will work for lowering. If you press the button for moving up or down harder, the header will move up or down with higher speed. The lifting and lowering speed is adjusted in the field copying system menu, but this point will be described later. These buttons on the joystick operate the modes of the field copying system. You can assign 2 out of 3 modes on each of the 2 buttons. In this part of the menu of the field copying system, You select one of the three modes and assign them onto the buttons. The next button is Harvester Emergency Stop. The emergency stop is used if you see that a foreign object got into the system. You can stop the harvester for the object not to go further in the system. If you do it on time, the object will not get into the feeder house or in the thrashing system. This way you will prevent the damage. This button also has got two stages of pressing. The lighter pressing switches off everything except the rotor and cleaning. By lighter pressing, you stop the following processes: the header, the reel, the unloading, the sieves adjustment, and folding or unfolding of the auger. If the grain tank roof is opening, it will stop. Also, one of the modes of field copying system will stop. If you press the button and hold it for 2 seconds, the rotor and cleaning drives will stop. So the whole technological process will stop. The field and road switch is located on the armrest. When you press this button, the indicator appears on the display. If this indicator is flashing during the road mode, the active processes are automatically switched off, and no process normally used in the field mode can be activated until you switch the road mode to the field mode. As all the field functions are blocked, even if you try to activate, for example, the auger extension, or when you simply accidentally press the button, you will see the notification that you can't use electrohydraulic functions while the road mode is on. It is recommended to use this function when transporting the harvester or on ordinary roads. So this function is used to prevent the switching on the working units accidentally. It is also recommended to use this function during maintenance or repairs. This will prevent the accidental activation of the working units. Field copying system. In the harvesting mode, you can see 3 columns on the display. These columns appear when this icon is active or when the thrasher is on. The harvesting mode switches on automatically, and on the left we see the 3 columns. These 3 columns represent 3 modes. The first column is pressure copying. This mode is used for harvesting lodge crops or dwarf crops. During this type of harvesting, the header slides on the ground, so the cutting length must be low, and one of such crops is soy, or you may need this length for harvesting peas. In case of really low wheat, we use this mode. Store the current pressure of the header on the soil, and the system maintains this pressure. The next mode is maintaining the cutting height. For example, you set the cutting height of 10 centimeters, and the system will maintain this height. If the header falls into a little pit in the field, the system will lift the header to 10 centimeters height. So in any extreme movement up or down, the copier will automatically come back to the 10 centimeters height. So the automatic mode is maintained for harvesting in the whole field, maintaining the cutting height. The last column is feeder house holding. In this mode, the cutting height is stable. It doesn't change depending on the irregularities of the field. If there is a hole in the field,
and the copier gets into it, the header remains stable. So the header will not change the position, as it normally does in other modes. In case of extreme difference on left or right copiers, and really high pressure on them, the header will tilt, but it will not be lifted or lowered. Sideways copying may work in this mode. Longitudinal copying with lifting and lowering the feeder house will not work. In the mode when the cutting height is maintained, the cutting height will be copied on the surface. If the field is bumpy, the cutting height will fluctuate. If the field is flat, the cutting height will be equal. If the field is not flat, but the irregularities are not big, the cutting height will be maintained smoothly. It will make no difference if the soil is wavy. In the case of big changes in the field, for example, a hole or a little hill, the cutting height will be increased in this patch of land. It will be considered an emergency lifting, but then the copier will return to the height you've set before. The numbers on the columns do not mean meters or centimeters. They show rough estimate in percent, from 0 to 100. The indication on this column shows the position of the feeder house transmitted from its position sensor. This position is when the feeder house is on the ground, and this one is when the feeder house in its extreme upper position. This column represents the position of the copiers. 0 represents when they are tight on the ground, and 100 shows their upper position, hanging on the chain. However, it doesn't mean that the header is on the ground, in its extreme low position. This column represents the data from the pressure sensor. From touch pressure to lifting pressure. Numbers 1 and 2 in the triangles represent the two modes. These are the buttons 1 and 2. You can assign 2 out of these 3 modes onto the buttons on the joystick. This means that these triangles can be assigned to any of the columns. Everything depends on the way we assign these modes. The T triangle represents the transport position of the header. This mode is normally used to turn the harvester around at the end of the field. So you lift the header, turn the combine round, lower the header, and then continue harvesting. So for this, you lift the header until the T mark. But first you have to activate this mode. To assign the necessary copying mode onto each of the buttons, enter the field copying system settings and assign the proper header control mode onto each of the buttons with numbers 1 and 2. Pressure copying, feeder house position, and the cutting height, the 3 columns we have. After you have selected the right mode, it's not enough to store it. To store the selected mode, you have to press the button and hold it for 2-3 seconds until you hear the confirmation signal. The confirmation signal will come from the display. For example, if you choose number 1, which is the copying pressure, this triangle will move to column 1.
If we press and hold the button 2, the triangle with number 2 will move to the column, which shows the position of the feeder house. So after the confirmation signal, the triangle will move to the column with indication constant. So after these procedures are complete, one of the modes is stored onto one of the buttons. After storing, you have to activate the mode. To activate it, you use the similar buttons. But this time, you don't need to hold the button. You press it once. You press it once, and the triangle becomes black. Here the indication shows that the first mode is active. So the copying is carried out in this mode, and all the functions are active. And the cutting height mode is assigned to button 1. If you press button 2, this triangle becomes white, and this one becomes black. The mode of the pressure of the header on the soil is activated. Before storing, you have to set the desired position of the header, the desired height. Then store this parameter, and then activate it. This table gives the description of the modes. Please note that the mode of keeping the header height is set as default. But of course, if you want to change it, you can easily do that in the settings. You can store 2 different modes on one height. Set the header to the height of 10 centimeters and assign different modes to buttons 1 and 2. For example, cutting height and the feeder house position. First activate 1, write down a few rows, then activate 2 and go a few rows. This way, you will be able to detect the optimum mode for yourself. Then you have transport position. It is represented by letter T. To store the desired transport position, use the header lifting and lowering button. Lift the header to the necessary height and position that you want to use when turning the harvester around. You can lift the header to its extreme upper position or halfway at 30%. It only depends on the driver's choice. Use this button to set the position, then enter field copying settings. There you will find the setting for the feeder house transport position in %. The setting is 50%. It'll be the stored position. Here, letter T shows 93%, which is the current position, and the header is almost in its extreme upper position. If you press this button, the value will be stored here, and the header in its almost extreme upper position will be stored as the transport position. So this means that you can lower the header to any position, 50 or 30% or maybe 60. Press the button and store it as the current transport position. So the next time you activate the header transport position, the header will be lifted to the current position you stored. To activate the transport position, press the button 1 or 2 twice. It doesn't matter which button you press. Press it twice, and the transport position is activated. The triangle with number 1 or 2 becomes white. The field copying system is switched off, and the transport position is activated, so the header is lifted. At this moment, you move out of the row, move to the end of the field, turn around, press 1 or 2 only once. The selected mode is activated, and you may continue harvesting. There is another way to change the transport position. You can press this sector on the display, and it becomes green. And using the wheel, you can change the parameter. Set the position of the header in %. The triangle will change its position on the column, depending on the value. You see that for each button, there is a copying parameter. Here you can choose the factory or user settings. It is recommended to use the factory settings. In the user settings, a driver or a mechanic may adjust the field copying system parameters. This is done in case the field copying system has to work with more sensitivity, so that the system reacts to any copier position change. If you don't want the system to react to any change in the soil, you can decrease the sensitivity in these settings. But be extra careful when you change this value. It is not recommended to change a number of values at the same time. Moreover, one might say it is prohibited, because when you change 3 or more parameters at the same time, the behavior of the header will change, but the driver will not be able to understand what the cause of this change was. A lot of time will be wasted to detect the cause of the problem. If you don't like the way the header behaves, and you want to adjust the proper functioning of the header, you have to change one parameter, then take a drive and monitor the header behavior, then make the necessary changes. Continue this procedure until you are completely satisfied with the header behavior.